Hello, everyone. My name is Masabali. I'll be presenting paper to code. So, in this recitation, we will be showing dummy demonstration for each part of how to code a paper, whether you should reproduce this paper or not, the motivation, and different things. So, coding a research paper transforms abstract ideas and mathematical formulations into practical, reproducible tools. It deepens your understanding where you dive into the core ideas by implementing the algorithms yourself, and you ensure reproducibility. So, in case you need to validate the results claimed in the paper, to confirm their accuracy and also to decide whether you need to add things on top of this paper. You need first to make sure that you can reproduce the same results. And then if you need to identify the limitation and improve them, you recognize the limitations in existing studies and build upon them to contribute new insights. So the first thing, should I reproduce this paper or not? Availability of official code. If the paper does not provide official code, replication becomes significantly more challenging. Consider whether sufficient details are provided, are available to guide implementation, such as algorithms, hyperparameters, and datasets. The second thing is like existing implementations. So some websites like Papers with Codes, which often list official or unofficial implementations. But also, you should be very cautious with unofficial implementations, as they may deviate from the original methodology. So, planning your implementation. By the way, your directory should always be in this structure. You should have a data loader, evaluation script, model script, training script. And here also you can put any of the pre-processing functions. So break the paper into components, the data pre-processing, data loader, the model architecture, and the training pipeline, and the evaluation matrix. And then you create a framework, a workflow, sorry. You list functions and modules required. Then you choose like which tools and frameworks you want to use, like for example, PyTorch or TensorFlow. You set up the environment, you install dependencies, you organize your project directory, and you should keep doing unit check one step at a time. Example, this paper is the MFA conformer paper, which is an architecture for automatic speaker verification. So the first step, when you have a paper, you check the dataset. You download the dataset. You obtain the dataset required for the paper, ensuring it matches the specifications such as the sampling rate. So you prepare the data, you split the dataset into training and evaluation sets based on the requirements of the study. You implement the dataset class, you write a custom dataset class to handle loading and pre-processing. By the way, you can also explore pre-built datasets on Hugging Face. And then you create a data loader uh, to efficiently batch and shuffle the data for training and evaluation. Like this is a simple dummy demonstration. So this could be a data loader file where you build, for example, in this paper, the MFA conformer paper, they used voxelib dataset. So this you can create the class for voxelib. Here, like you read the CSV file using pandas. You get access to the utterances, the paths of each utterance. To get in each item, you get like a waveform with its corresponding label, and then you return the sample. So this is the dataset creation. You split it into train, validation, test set, and then you create a data loader for each split. And the second part is the model. So actually you leverage pre-trained models. You can use any of the off-the-shelf models to speed up the development. You would find like, for example, like there are popular sources like Tim and Hugging Face, where you can get any of these models like MFA conformer or any other models. Input and output verification, you ensure that the input shape matches the model requirements, like image dimensions, sequence lengths, and etc. You validate the output to confirm it aligns with the paper's description. Like, for example, if the output is embedding class probability. The tips for customization is like you have to fine-tune pre-trained weights for better results. So, like for example, this is the MFA conformer model. You put it in a model.py file. So like any other model, like for example, if you're using transformer, whatever you're using, you just put it in a separate file. Then the training script. You should have a training loop. You write a function to handle training for each epoch. You update model parameters using backpropagation and the optimizer. Validation loop, you include a separate function for evaluating the model on validation data. You track performance matrix like accuracy or loss. You save the checkpoints, so you save model checkpoints. You can save them like at regular intervals or based on the performance improvements. You ensure checkpoints. Checkpointing includes the model state, optimizer state, and the epoch number. For the logging, you log training and validation loss, accuracy, and other metrics for each epoch. You use tools like TensorBoard, weights and biases, or simple console print statements. So this is the training script. You can also you put it also in a separate file. Like so, for example, this is the training one epoch. You here do the forward pass, backward pass, the matrix, anything you want, the loss, accuracy, validation. So you make sure you put model.eval. Here you save the checkpoints. Here you train the model. And then you save the checkpoints. For example, like when you call save checkpoints, you can add any criteria you want on here, like checking the accuracy or the loss based on the validation set performance. So here, like this is optimizer, loss, and just you call them. Then the evaluation. So the purpose of evaluation, it's your evaluation code ensures the model's performance is measured accurately using the test set. And like matrix of interest is like define the matrix to evaluate such as accuracy, precision, recall, F1 score, or domain-specific matrix like EER for speaker verification, for example. And this is the script for the evaluation. So evaluating the model. Again, it's very similar to the validation. You just also, this is the model.eval. You compute the accuracy and you compute whatever you want on your test set. And here are the references and further readings. And for the ablation, so if you're running different experiments, you organize your folders. You use meaningful folder names, such as experiment number for each experiment to keep the results separate and identifiable. You maintain a YAML file for each experiment to store hyperparameters, experiment directory name, other relevant settings. So this allows you to modify hyperparameters and other settings without directly editing the code. And then you track with weights and biases. So you use it to log experiment details, including matrix and hyperparameters and results. You assign unique names to experiments within the same project using the YAML configuration file. And this is how you code a paper. Thank you.